Okay, this video is going to go over types of systems, and we have a few different categories for these. So the first type of systems that we're going to look at are static and dynamic systems. So a static element or a system, for those things, we have an output at time t that only depends on our input at time t. And an example for this would be like a currency exchange. So if we have a U, which is our input, which is $100 US, that goes into a currency exchange where we're trying to convert to Canadian dollars, we'll end up with $125 in this case. And that is a static system in this case because our input directly affects our output. There's nothing else that affects it besides our parameters. Another example would be a resistor. Our voltage is a function of our resistance times our input, which is our current I here. So our voltage is our output. In general, static systems have algebraic equations. So y is equal to a times u, y is equal to a times u plus b, y is equal to a times u squared plus b times square root of u, etc. On the other hand, for dynamic systems, a dynamic element or system has an output at time t that depends on both the input at time t and past inputs. A dynamic system has memory. An example for this would be a bank account. So let's say we have a bank account, we have Y, which is our output, that's our amount saved, and U is the amount that we're adding in. And let's say for day zero, this is what we're starting out with. This is our initial condition. We have $5,000 in our bank account. Now, on the first day, we add in $1,200, which gives us $6,200 equivalent into the bank. On the second day, we add in the same input, but we end up with $7,400 in the bank. So even though that the money, our input is added the same both days, so U2 is equal to U1, the total amount in the account is not the same. Y2 is not equal to Y1 in this case. This is a sense, this shows an example of a dynamic system. And as we may see later, initial conditions relate to memory and their past inputs. So in general, dynamic systems are described by differential equations. So for example, y dot, which is the derivative of y with respect to time, is equal to u. Y dot is equal to a times u squared plus bu. Y dot is equal to a times y plus bu, etc. We can have second order derivatives, y double dot plus b times y dot, for example, to have in these differential equations. That's okay as well. So for our second category, we have not linear versus nonlinear systems. So a linear system has equations that obey the principle of superposition. So if we have an input u1 and we put that into our system, we're going to get an output of y1. If we have an input u2 going into our system, a different value than u1, we're going to get y2 out of it. And if we have a times u1 plus b times u2, we're going to get a combination of those, a times y1 plus b times y2, out of our system. So that is what superposition is. So what does this really generally mean for us? Well, if we have y dot, y double dot, we cannot have any derivative term or any y term. We cannot have any of those to a power, so we cannot have y squared, y cubed, y dot squared, etc. And we cannot have any of these multiplied by each other. So we cannot have y times y dot or y times y double dot, for example. If any of those are true, then that's considered nonlinear. So for a few examples, linear versus nonlinear systems, y is equal to au plus b. That is a linear example. A times y double dot plus b times y dot plus c times y is equal to u. That is also a linear system. A nonlinear system, for example, would be y squared is equal to a times u, because we have a y squared term. If we have sine squared, sine of y squared is equal to u, that's also nonlinear. And if we have y times y dot is equal to u, that's also a nonlinear system. Okay, and our third category of different types of systems is time invariant versus time varying or time variant systems. So if we have those equations similar to what we had before, if their coefficients or their parameters are constant, that are multiplied by y dot, etc., then the system is time invariant. However, if they depend on time, if any of those parameters depend on time, it is a time variant or time varying system. So for an example here, comparing two different cases, the one on the left is our time invariant system because A, B, and C are all constant. They do not depend on time. Whereas in the other case, on our right, we have A, which is a function of t. That makes this a time variant or time varying system. And in this case, we still have a linear system. There is no y dot times y or y squared in there. So it is still linear, but it is time varying with respect to the coefficient for y double dot. And that covers our different types of systems.